record. All right, so today we're going to take a look at chapter 4 in the textbook, which talks about, it's called interface design, but it's basically a chapter about thinking about the functions that you are going to write and how they should kind of work together. And if you think carefully about your functions, you can design complex programs and not stress too much about how they're going to work. Okay, and so to illustrate, we're going to use this kind of this module called Turtle Graphics. Okay, Turtle Graphics is something that kind of comes with base Python, and if you want to use it for a Jupyter notebook, there's certain things that you have to do to get it to run in a Jupyter notebook. So here, let me, so what you'll need to do is you'll need to open a terminal window, okay? Or on your computer, you'll have to choose kind of the Anaconda prompt. So under Anaconda, you can choose the Anaconda prompt or the Anaconda PowerShell prompt if you're a PC user, or if you're a Mac user, you're going to open up some kind of terminal window, and then you'll run pip install ipyturtle. Okay, I've already done this, but if you want to follow along, you can do this. Oops. ipyturtle. How do I make my? Let me see if I can make my font bigger for you guys. Okay, so you're going to run pip install ipyturtle, and it's going to download and install stuff. Mine already says everything's already installed, requirement already satisfied, but probably not for you. So you're going to have to run that. So that is right there, pip install ipyturtle. And then you have to enable the extension so it runs in Jupyter. So you're going to type in Jupyter nb extension enable --pi --sys prefix space ipyturtle. Okay, so you're going to have to type all of that in there. I guess I can copy this into the chat. So that's the first one, and that's the second command that you're going to have to run. Okay, and then it'll say validating. Okay, all right. Okay, great. And then what you'll need to do is, if you already started up Jupyter Notebook, you're going to have to restart Jupyter Notebook. So where is it for me? I'd come along here, start my terminal, type in Jupyter Notebook to get it running. So now that all of that's been activated, Jupyter Notebook will start running. I can open up this this notebook, 301. And this should work. Okay. I'm not sure if you guys are choosing to follow along or choosing not to follow along. So anyway, you'll need to get that set up. Okay. And this is how it works. First, how do you know if it worked? Well, you'll start when you start up your notebook. You'll come to this first cell that says from ipyturtle import turtle. And you're going to hit Shift Enter to run it. So I guess what you can do is you can do kernel restart and clear output, and that should restart everything and clear all of your cells so they're blank. So that's restart and clear output, and then you're going to run this cell. Okay, And if this cell runs without throwing an error, then that's a good sign, okay? Because you want to be able to run that. So from IPyTurtle, import turtle, and then we're going to call, we're going to create a turtle, okay? And I guess the turtle that we're going to call is going to be Bob equals turtle. Okay, where do we type in the commands? You're going to type it into some kind of terminal window. So either on Mac, you're going to open up a terminal, and you'll type these commands in there. Or if you're on a Windows machine, you're going to come and you're going to have to start up kind of Anaconda prompt. So in your Windows machine, I have an Anaconda folder, and Anaconda prompt is there. If you're on a Windows machine, I would just pin this prompt to the start menu. Okay, that's what I've got right here. Okay, and then the next cell you're going to run is you're going to do Bob, or just you're going to create a turtle. We're going to create one called Bob, and then if you hit type execute just Bob, it should pull up a window here with and this little arrow represents Bob the turtle. Okay. The base turtle graphics and the IPyTurtle. So the IPyTurtle is something that is compatible with IPython, which Jupyter runs, and it's a tiny bit different from your base turtle graphics. So turtle graphics has been around for a while, and IPyTurtle is kind of an adaptation of it. So when you read the textbook Think Python, it uses the base turtle graphics thing, which is pretty similar, and you can follow it along for most of these things, but there are slight differences. So just be aware of that. Okay, so again, I don't know who's following along, but is this working? Is this throwing errors for anybody? You guys are working? Okay, great, great. Okay, all right, and so you can give it some very basic commands. So there's forward and backward, which will move your turtle forward or backward. And then there's right and left, which will turn the turtle right or left a certain number of degrees. Okay, so here I'm going to hit Shift Enter to move our turtle Bob forward 40 whatever pixels, 40 units. Okay, so so he moves forward. Then we're going to say turn left 90 degrees, and so so the arrow is going to turn left like that. And then I can move him forward 100. And then I'll have him turn right 90 degrees. And then I'll have him move forward 40, okay? Okay, and that's your basic functionality here, okay? And so we're gonna use this as kind of a framework for just thinking about functions and loops and stuff. Okay, Jason Lim says, I'm having trouble getting the window with the turtle to appear. Okay, did you run both of these commands? Did you, and then did you restart your Jupyter Notebook? So, so there's a few things. You got to do it in order. First, you've got to run pip install IPyTurtle in your terminal window. After that, you've got to run this command, okay? And so I'm assuming you ran both of these commands. And then after you do that, you've got to kind of shut down your, make sure Jupyter Notebook is not already running, okay? And then you will start Jupyter Notebook afresh. Okay, Hannah Lim is saying she has the same problem. And so, I don't know, have you guys tried restarting your Jupyter kernel? By, starting and then you did IPyTurtle here, and then you created a new instance of the turtle, and then you're just calling Bob by itself. Okay. All All right. Well, we'll have to see what happens. Okay. All right. So if it shows up, this little thing should pop up, and we've got him to move. Okay. And then to kind of just reset him to be in the. How do you restart the kernel again? So I closed everything out, and then I just open a new kind of PowerShell prompt or a terminal window, and then you just type in Jupyter Notebook. Okay, just to kind of get Jupyter Notebook running all over again. Okay, to reset him in the window, you type bob.reset. Okay. All right, maybe I'll just get a pulse in the classroom. Okay, if you are trying to follow along and Turtle Graphics is not working for you, give me a red X. Okay. Whereas if you are trying to follow along and it is working for you, give me a green check. And if I guess if you're just watching me and not trying to actually follow along on your own computer, you don't have to tell me anything. Okay, so I guess maybe about 18 of you are trying to follow along, 19, 20, and we're getting, okay, so those of you who are experiencing trouble, what can you guys tell me what you have done? You can feel free to unmute yourself and just chime in here.
So for me, I've installed everything. I ran the commands, no errors were thrown, but then just when I run Bob, no window pops up.
Okay, and you restarted the kernel and everything?
Yeah.
Okay. So you imported Turtle from IPyTurtle, import Turtle. I don't know, maybe just try opening a brand new notebook. Do a new Python 3 notebook. And then try from IPyTurtle, import Turtle. And then, create a new turtle called Bob or whatever you want to call him. I'm not sure why it wouldn't work on your thing. And then call Bob. Okay. Anybody else? I'm sorry. I don't know if, what else to say right now. The other people with red X's, are you guys okay, or are you able to tell me what's going on? Okay. Well, your mind says from is not recognized. Okay, that's a more serious problem because from is just a universal Python command. From is not recognized as an internal or external command. Okay. I'll have to probably meet with students after class to try to solve some of these things. Okay. Let me keep moving forward here. And then we'll try to resolve some of these issues. Okay. So so here I ran reset on Bob to get him back in the center. Okay. And then so let's say if we want to draw a square, we can say go forward 100, then turn left 90, go forward 100, turn left 90, forward 100, turn left 90, forward 100, and then turn left 90, and that should reset it. Okay, so he's gone forward, turned left, forward, turn left, forward, turn left, forward, turn left. Okay, and so when you write the same command over and over and over again, that's kind of the perfect setup to create a for loop, right? And so so let me just kind of reset this. And what I'm going to do is I'm going to run a for loop with for I in range 4. Okay, range 4 is Python creates what's called a range object, which is basically equivalent to the numbers 0, 1, 2, 3, okay? Python uses zero indexing, so it starts at 0. It's going to have a length of 4 when you say range 4, so it's going to go 0, 1, 2, 3. And basically, for each of those iterations, I starts off at 0, then I becomes 1, then I becomes 2, and then I becomes 3. And it's going to run this code. So it's going to run this code 4 times, which will also draw the square. So that's a for loop, and the way we specify the for loop is you just say for I in, and then you provide it the range with a colon. Okay, so you would write it this way, and then these two lines that are indented are going to be associated with the for loop, right? If I had another line. So if I did this instead, okay, then what will happen is it will move Bob forward 100. Here, maybe I'll just do it 10. Okay, it'll move Bob forward 10 4 times, but and then only after it has finished the loop will it run turn left. So it'll move Bob basically 40 pixels forward and then turn left. Okay, which is not what we want. Whereas if I indent Bob left, okay, now Bob turning left is associated with each iteration of the for loop, and we'll get a square with each side being 10 pixels long, okay? So we get this tiny little square here. So Python associates lines of code with a for loop using indentation. No curly braces or anything like that. Right? And here I can create a function. Okay, I can create a function called square. All right, and with square, it will. All I'm doing is I'm just drawing the square. Okay, go forward 100 and turn left 90 degrees, and do that 4 times. And we're going to throw that into a function called square. Okay, and so this defines the function square. And I'm going to, again, reset my picture. And then when I call square, it'll draw the square. Okay, it's just running this. Okay, and so so this is called encapsulation. When you take a piece of code and you put it inside a function, okay, now we've given basically these lines of code, these 3 lines of code, a name, right? And that allows me to kind of just refer to this function of drawing a square. It allows me to just to draw a square just by calling the function name square, right? So it's very useful to have basically shortcuts for a sequence of events. Okay, so in this case, when we call square, it's going to go forward and turn left, and it's going to do that 4 times, right? Rather than having to list off every single command, you can just say, you know what? It's just like telling somebody, you know, drive to school. Rather than having to say every single time, okay, exit the driveway, turn left, go forward 2 miles, turn left at, you know, this street, and then drive forward 6 miles and turn right. You can just give it a name, give that sequence of directions, you know, the command drive to school or something like that, okay? And so that's what we call encapsulation, all right? Let me just take a side note and just talk a little bit about how Python uses indentation to associate lines rather than curly braces, and a side note on the range object, which we saw earlier for the for loop. Okay, we haven't formally covered if statements. If statements, I think you guys are already familiar with if statements, but I guess we'll talk about them a little bit more formally in a moment. Okay, in a future lecture, I guess. But basically, if you guys look at this line of code, what it does is it evaluates this. X is greater than 8, okay? Or X is 8, and it evaluates the if statement. If X is greater than 5, then print these things, okay? So it's going to print x is greater than 5, it's going to print out the value of x, which is 8, okay? And it will only do these things if the if statement is true, okay? Whereas this line, print hello, will run whether the if statement is true or false, okay? So here x is equal to 8, and I'm going to run it, and it's going to print all 3 lines because this statement is true, okay? Whereas if I changed, if I ran the exact same code, okay, with x equal to 4, okay, these 2 lines will not run, but print hello will run because it is not indented. So this print line is not associated with the if statement, whereas these print lines are indented, so they are associated with the if statement. Okay, and again, we don't use curly braces in Python, okay? And you will appreciate this indentation. It truly makes the code a lot easier to read, okay? All right, so what's gonna happen here with this line? What's gonna get printed out? If you just, okay. So here, because x is greater than 5 is indented, but print x is not indented, it's gonna, whether or not this is true, these 2 lines of code are gonna get run. So it's gonna print out a 4, and then it's gonna print out a hello. Okay, so so indentation is makes all the difference as far as code chunks go. And the same thing applies when you have for loops or any kind of loops. The indented lines of code are associated, and non-indented lines are not associated. Okay, which when you type in Jupyter and IPython, it automatically will indent for you, right? So if you just say for x in range 5, colon, okay, and as soon as you hit enter, it automatically already indents for you, right? So you can just say print x, and then you can say print next line or whatever, right? And it's only until you hit backspace that you're no longer associated with the loop, right? Or you can hit tab to get back into the loop, okay? And you can just say print done, okay? And so there you go, right? 0, next line 1, next line 2, next line 3, next line 4, next line, done. Okay. Whereas here, if I take out the indent on next line, it'll just do 0, 1, 2, 3, 4, next line done, okay? Which, depending on what you want it to do. And then if you just throw in an indent for no good reason, Python's gonna get angry at you, okay? It's gonna say unexpected indent, right? It got an indent, and it says there shouldn't be an indent here, okay? So it doesn't let you indent just for funsies, okay? You've got to, there's got to be a reason for it, okay? And again, any line that ends with a colon, which is going to be an if statement or a loop statement, is going to run some kind of indent, have an indentation afterwards. Okay. And then the other thing we need to talk about is the range object, okay? So the range object, when you do range 10, it's kind of like creating a vector 0, 9, okay? And it creates an index that is 10 items long, but starts at 0. So it's going to start at 0 and at 9. And then the general format for range is this function where you give it a start value, okay, an end value, and a step size, all right? But if you don't provide it the start and end and step size like this, and you just give it 10, then it's going to assume a step size of 1 and a start value of 0, basically, okay? So here, we're going to do range 10, and it creates a range 0, 10 object. That's kind of the default behavior here. And if I say for I in range 10, we can have it run the print statement, okay? And by default, print will automatically throw in a new line character, but you can give print the optional argument end, and we're going to just have it put in a space here. So this is going to print out the the integers 0 through 9. Okay, just like that. Okay. If you do, say, range 5, 10, you'll get a range 5, 10 object. And just so we can see what these values will be, okay, these will go starting at 5, going up to, but not including 10, okay? So you can throw them into a list if you want to see the actual values. And so this will be 5, 6, 7, 8, 9, right? Okay, so here I've got range 0, 20, step size 2. So what will be the biggest number in this list here? What do you guys think?
18.
18, yeah, okay. So it goes up to, but not including the last number. So it's gonna go 0 to, going by even numbers, it's gonna go up to 18, right? What about this one? 0, 21, 2. This will end at 20, okay? So it goes up to, but doesn't include the final number, right? If you try to do something like range 0, 20.1, R throws an error here, okay? It says float object can't be interpreted as an integer. It says, you can't do this. Can you do it backwards, like range 10, 5? Yep. Oh, I'm sorry. You go, I'm sorry. You can do backwards, okay? But you go by -1. Well, let me see. Am I doing this right? I think we do, sorry. 10, 5, -1, sorry. That's how you do it, yeah. So if you want to do backwards, that's fine. You just have to specify that the step size is a negative number. Yeah, so yeah, if you don't specify the negative, then you'll get an empty list here. Okay. All right. So okay. So those are our side notes talking about indentation and range objects. Okay. So anyway, here is I've done. So one thing about writing functions is you want to generalize it. Okay. And so our old function for drawing a square is specific to Bob. Okay. It's specific to Bob. So what I can do is I can just generalize it to any turtle, okay? Any turtle t, okay? So square t here is going to take any turtle, and then it's going to call turtle forward 100, turtle left 90, okay? So here I can reset Bob and draw a square for Bob, okay? If I wanted to, we can draw another, create another turtle. Carl will be a new turtle, okay? And if I call Carl, it will, then we'll get, so unfortunately we can't really see it here, but I guess I can do Carl's pen color is blue, and then we'll call Carl here to get his, and then we can call draw a square for Carl, and we'll get Carl's square, okay? But then we'll probably want to switch back to Bob. So I'll call Bob, okay? So we have different, you can have different turtles, but you kind of have to call their name to see their window here, okay? So Carl's color is blue, and so we can do that. We can draw Carl over here. Is there a question over there? Okay. All right, so here I'm going to further generalize, okay, the function by throwing in a variable for length. An argument for length. All right, and so here I can say, let's draw a square with a side of length 40, or we can I'll square on Bob with a side of length, say, I don't know, 120. Okay. So this is all just part of generalization. And so, one strategy for, writing a function and getting something to work is you should always just think about kind of just a simple example and simple version of it, and just see if you can get code to run there. And then once you get the code running, then you can think about encapsulating and generalizing it, okay? So usually if I need to accomplish a task, I'll just think, okay, before I even think about writing it as a function, I will just think about the code that needs to be written for just a single instance. And then once I can get it running for a single instance, then I can think about generalizing it into some kind of function here, okay? And so here I ran ahead and created a polygon function, but so we can make a polygon function. So what if I said, can we draw a pentagon? Okay, so a pentagon has 5 sides, all right? So, so in this case, we would probably have to create, let's just say we want to do a for loop. Okay, and for a pentagon, what is the angle that we need to take, right? So for a square, the 5 angles, or the 4 angles, are each 90 degrees, okay? Which means all 4 angles add up to 360 degrees. And similarly, for a pentagon, when you take, when you turn, okay, for a pentagon, the how much it turns is not going to be, is no longer going to be 90, but it's going to be more of a shallow angle, right? So if you think about it, okay, so if you draw a pentagon, each of the angles are, the interior angle is bigger, but the amount that the turtle itself turns is less than 90. Okay, so the interior angle is greater than 90 degrees, but the angle that the turtle turns is actually is very quite simple. It's 360 divided by 5. Okay, the turtle turns 72 degrees is the angle that he's going to do. So so actually the angle is going to be that, and then we would just go, we would move Bob forward. Let's have him move forward 50, and then we'll have Bob turn left, this angle of 72 degrees. Okay, and this will draw a pentagon. Okay, because when he starts up here, he only has to turn 72 degrees, and then he makes this, completes the pentagon there, right? And if we want to say, okay, well, how can we generalize to, say, a hexagon, okay? Okay, with a hexagon, the interior angle is 120 degrees, but the angle that Bob himself has to turn, the turtle itself has to turn, is only 60 degrees, okay? All right, and so there it is for a hexagon. Okay, so how can we generalize this? Well, if you try it out for a couple instances, then you can say, okay, well, the angle is actually quite simple to find. We just do 360 divided by the number of sides, okay? So we can replace the 5 and the 6 with an n, and then the range can, the value that goes inside the range can also be replaced with an n, okay? So after creating the code for a pentagon and hexagon, okay, we can generalize to a n-sided polygon, right? And so here we're going to define a function called polygon, and the angle is going to be 360 over n. We call the range, and we do this, okay? So sometimes students, when trying to think of functions, will immediately start writing up the function, okay? And I'd say this is not a good strategy. Always think of trying to do a concrete example where you know what the numbers should be, where you know what the output should be, and then get it running there. And then if you can get it running there, then you can try to identify some kind of pattern between different versions of this, and you can say, okay, well, let's try drawing a triangle. Let's try drawing, a pentagon. Let's try drawing a, 7-sided, I don't know, septagon or something like that, okay? All right, what if we wanted to make a circle, okay? Well, there isn't an easy way to make a circle, but what you can do is you can just kind of get an approximate circle. And this approximate circle will basically be, in our case, will be a 50-sided polygon, okay? So, so what we're gonna do is for the call to a circle, rather than rewriting the code to make the polygon and saying take the angle and divide by 50, I'm gonna just call the function polygon from inside circle, okay? So no need to rewrite the code, just call the function. So we're going to call the function for polygon within the code for circle, okay? And as far as circle goes, all it's trying to do is figure out the length of each side to use, okay? And then it's going to pass on the argument 50 here, okay? So as far as the length, all right, as far as the circle goes, we need the radius, okay? So how big is the radius that we want, okay? As far as the radius goes, we want a radius of r. And so the circle, the total circumference is going to be 2 pi r. And the length of each side is going to be basically the circumference divided by 50 in our case. Okay, so here, maybe I'll go ahead and I'll reset this, and it draws a circle there, okay? Maybe I won't. Here we'll draw a circle with a radius of 100. Maybe I'll try drawing a circle with a radius of 20. Okay, so here we get different circles drawn for with our turtle here. Okay, and again, if we pause and think about the code, we don't have to rewrite all of the code. We can call functions that we've already defined, right? So rather than having to draw a whole nother loop in here, we can just call polygon from inside of here. Okay. One issue with defining our function for circle like this is that we have decided arbitrarily to just say, let's draw a 50-sided polygon, okay? Now, a 50-sided polygon, maybe that's okay, but if you have a really big circle, what's gonna is that with a really big circle, it's going to become clear that that it's a polygon, okay? That each side is going to be kind of a straight line here. So in certain instances, we might not want to just leave it at 50, a 50-sided polygon, okay? And so what we can do is we can refine the definition of circle here, okay? And so so when you think about how a user is going to interact with a function, you want your function to be able to do basically what the user needs it to do. But you don't want to make your user have to think about some unnecessary stuff, okay? So it's true. And rather than saying n equals 50, you could just pass that responsibility onto the user. You could say, you know, user, how many sides do you want your polygon to be? Your circle approximation, how many sides do you want? Do you want 50? Do you want 100? Do you want 20? And you can put that burden onto as a value that the user needs to input, okay? However, it's probably better off, as far as a circle goes, the user is not going to think, how many sides do I need to use to approximate my circle? When a user thinks, like, I want to draw a circle, they're drawing a circle, okay? As far as they're concerned, a circle has only one edge. It's not really a polygon. So the decision for how far the turtle should travel before turning should be hidden from the user. So the interface that the user interacts with the user should just specify which turtle should draw the circle and the radius of the circle itself. Okay, and then the rest, as far as how many sides, okay, if we want to make this a variable, we should decide this ourselves. Okay, so within the function, we have defined and said, you know, the number of sides to draw is going to depend on the size of the circumference. If the circumference is huge, the number of sides should go up. If the circumference is tiny, the number of sides can go down. And so we're going to take circumference and divide by 3, and we're going to make it an integer. By throwing it into an integer, we're going to take the integer portion of this, okay? Because anytime you do division, you're going to get a float number. So we're going to turn that back into an integer. We'll add 1 just kind of for room for cushion, and then from there we can decide how long our length needs to be, and we'll pass those arguments onto polygon. Okay, so therefore we don't need to worry about this. We can call circle on with a radius of 20, circle with a radius of 50. It's struggling a little bit there. And we can call it on a big number like 500, and it'll probably take a long time to draw. But it shouldn't be noticeable that it is a bunch of polygons, okay? Something happened. We broke. We broke the turtle. Can you okay, yeah, to force stop, you can hit this stop button right here. There's a stop button on the toolbar to stop a thing, but it takes a little while to respond. Okay, yeah, that can happen with the with running the turtles. The turtles are like intentionally slow. It's so you can kind of see the paths and the arcs draw. Okay. Obviously, okay. Oh, we're gonna run out of time. All right. What if we want to write a function for creating an arc? Not an entire circle, but just say an arc. Let's say you wanted to do a sweep of, let's say, 1/6 of a circle. Okay. So so in this case, we would need to specify two arguments, right? We would need the radius of the arc, okay, and the angle of the arc, right? So we don't want to draw We don't want to draw the full circle, but we want it to stop, right? Okay, so basically, so how would we think about this? So, so here, let's think about how we drew the circle, okay? For the circle we called polygon, okay? But we don't want to do polygon, which is going to basically complete the whole thing, but we want it to stop after a certain number of iterations. So, so what we can do is, so here we can kind of define the whole thing in one go, all right? So we can define here, let's just do an example, right? Okay, so so again, before jumping straight into defining the function, let's draw an arc, okay, with radius 50 and it will be 60 degrees, okay? Okay, 1/6 of the circle. Okay, so how would we go about something like this, right? So we kind of want, so thinking about a polygon, so we would say, we can say, all right, so the circumference would be equal to math.pi times 2 times the radius, okay? So if I can say radius is equal to 50, and we'll say angle equals 60 here, okay? Okay, so that would be the full circumference, and then as far as the arc length, the arc length would be this times basically the fraction, the 1/6. So this would be 60 divided by 360, right? So this would be the circumference. So maybe I should write this instead. Okay, so we only want 1/6 of the circumference as far as the arc length goes, okay? And then, okay, so now we want to draw kind of, doing kind of like a polygon. So maybe I'll just, we'll say n is equal to arbitrary number, we'll say 30, okay? So, or this will be kind of our steps. And then what would we want to do? We would want to do for I in range n, we would have it, we would have Bob go forward some, okay. So our step size, sorry, step size would be the arc length divided by the number of steps, right? Okay, so we'll do, so we'll move Bob forward, the step size, okay? And then how far should he turn? Well, the angle, we'll have Bob turn left, basically the angle, so our step angle will be the total angle divided by n, okay? Okay, so let's do a Bob reset here. So reset Bob, and then we'll just try this, okay? Okay, that looks okay. And if I ran this again, it goes another 1/6 and another 1/6. Okay, so that seems reasonable. What happens if I change the radius to say 100 and I change my angle to say 30? Does this still work? Okay. And that seems like it's good, working well. Okay. So now we want to say, okay, well, here is our bit of code. Oh, I'm sorry, I'm way over my time here. But basically, we've tried it out. we've looked at how we can modify the code, and now we want to be able to encapsulate and generalize this, right? So perhaps we can pass on replace r and angle with arguments that go into a function, okay? And then, and here, we've just arbitrarily chosen 30 for the number of steps, but perhaps we would want to then generalize this to be related to exactly the radius and how big of an arc that we are drawing, right? So this is first we get it to work for some specified version, okay, and then think about how it can be generalized into an actual function, okay. So I would leave that to think about how to generalize this to a function. Okay, so always start with some kind of, always start with some concrete example where you know what the result should be. And then once you get it working for a concrete example, then you can think about generalizing it to a more general example. And then if you can think of it to get it to generalize for a more general example, then you can further optimize it and break out chunks that are repeated. Okay, sorry for going a little bit over here, and but that will be it for today. I hope the homework's going well. Keep up with the stuff on DataCamp as well, and I'll post kind of the. Oh yeah, I forgot about the quizzes today. Totally forgot. Thank you for reminding me. Quiz answers for today are A as in apple and D as in dog. First question is A as in apple. Second question is D as in dog. Okay, do you guys all get that? A as in apple for the first question, D as in dog for the second question. Thanks for sticking around. Okay, so I'm going to stop the recording. Some of you guys experienced some trouble with